This is Higher Maths. It's revision for differentiation. It was given out as a homework, but there's plenty of questions here for you to try. And what you can do is try them and see how the solution works out the way that I do it. So there's a number of questions. I think we're up to 9 questions if you look through the sheet. This was a sheet that was made up by one of my colleagues. So we're going to go ahead and we're going to answer each of these questions one by one, and I'll give you a description of how I would go about them. Okay, right, first thing we're going to do is we're going to do some of these here. Okay, so we're going to find the derivative of each function, so that's going to be differentiation. Okay, so first thing we're going to differentiate. I'm going to look and see if it's set up in a manner where I can differentiate. There's no roots and there's no x values on the denominators, so I can go ahead and do that. Right, let's go ahead and differentiate it. So we'll say that's f dashed x is equal to, and we've got 3x squared. So remember, it's 3 times the 1 that's sitting at the front, which will give us the 3 there, x, and we're going to reduce the power by 1 down to 2. Okay, that's a normal process we'll follow for differentiation. I'll just follow through this question here. So it's going to be plus 4x to the power of 1, and then that will be plus 6, and then the 1 goes to 0. Okay, so that would be my final answer there for finding the derivative or differentiating it. Okay, part B. Let's go ahead and do these. Right, so I've got an x value on the bottom. I'm going to have to make sure I can prepare that properly. So the first thing that I'm going to do is I'm going to lift that to the top, and I'm going to make it a negative. So if I just take it from there to there, it's going to be negative. I'm now going to differentiate it. So f dashed x, that times that gives me minus 8x, and then when I subtract 1 from it, it's going to take me down to minus 5. Okay. This one here, for part C, I'm going to have to differentiate this. I'm going to have to prepare this part. This part's ready for differentiation. So first thing is going to be preparing. And again, same thing, I'm going to lift that to the top, and it's going to be a negative 2 that's going to go there. Okay, so let's go and differentiate it. It's going to be 8x to the power of 1 minus 2 times the minus 3. That'll give me a positive 6x to the power of minus 3. Okay. Next one. Okay, we've got 6, and that's root x that's there. Right, for that one there, I'm going to have to prepare it because I can't differentiate when I've got a rooted form that's there. So we'll change that to 6x, and remember the way the roots work. There's a 2 that's sitting there if it's a square root, and a 1 that's sitting there as a power. So the power would go on the top. The root, just like a flower, goes to the bottom. Okay, so root x is x to the power of a half. Okay, I've got 6 in front, so it's 6x to the power of a half. I'm going to differentiate it. Half times 6 is going to give me 3x to the power of minus a half. So if I take 1 away from that. Okay. On to E. This is 1E. And we're finding the derivative of these functions. Okay, for this one here, it's not prepared well enough for me. I'm going to have to multiply that bracket out. So I'll just go ahead and do that. And that'll be it prepared to go. Okay, so that'll be 2x cubed. That'll give me plus 6x squared. From there, I can go ahead and differentiate it. There we go. So that'll be 6x to the power of 2, and that'll be plus 12x to the power of 1. Okay, and that's me done that one. For f, can't differentiate with the x values on the bottom. So for this one here, what I'm going to look at is I'm going to be lifting only, and you need to watch out for this part, it's only the 6, the x to the power of 6, that I'm going to be taking to the top. The only thing with the power of 6 there is the x value. So what we're doing is we're moving that one up to the top. Okay. So what I've got, the number that I've got there is sitting as a half. So there's my half that's sitting there. Up to the top would be x to the power of minus 6. Now I'm going to go ahead and differentiate it. So a half of minus 6, that's going to give me minus 3, negative 3, and that will give us x to the power of minus or negative 7. Okay. Right, so moving down to G. For g, got a combination of things here that I'm going to have to sort out. I'm going to have to square this bracket out first, and then what I'll do is I'll multiply it by the x value that's sitting at the front there. So what I would do is I'd multiply that out by FOIL. So if I multiplied that out by FOIL, that would be two brackets. I'm just going to show it that way, okay? So x minus 3, x minus 3. I'll multiply the bracketed terms out first. So that'll give me x squared. Give me minus 3x minus another 3x. That'll be minus 6x. And the minus 3 times the minus 3 is going to give me a positive 9. Okay. The other way I can do that, remember, is I can square that term. I can multiply these two terms together, okay, and double it. And then I'll square this term. And just be careful of that sign that would be there, because that'll go to a positive 9. Let's multiply this out by x. So that's going to be x cubed minus 6x squared, and that'll be plus 9x. I'm going to differentiate it right now. So that's going to be 3x to the power of 2 minus 12x, and there we go, 9. Or 9x to the power of 0, x to the power of 0 equaling 1, so that just leaves it as a 9 that's going to be there. This type of question here for h, got to be careful of these ones. The way that I like to approach them, I like to split the fraction out. So I'm going to put the denominator under each of these numerators that are there. So we're going to go ahead and do that first. So I've got 2x to the power of 6, that's all over x squared, plus 1 over x squared. From there, what I can do is I can sort out the indices like I would do in National 5. So I know that when I'm dividing x's with indices, I'm going to subtract the indices. So that will give me 2x to the power of 4. That's 6 minus 2. Okay. This one here, I'm going to be taking that to the top there, and that's going to give me a plus x to the power of minus 2. I'm going to differentiate it now. That's it prepared and ready to go. So I've got 8x cubed. That's going to be minus 2x to the minus 3. Okay, so that's the question 1 complete. That's questions A through to H. That's that done. Okay, let's move ahead to question 2. Okay. Right, question 2. Given that f of x is equal to x cubed plus 2x squared minus 7, find the value of f, there's the dash there, f dashed 2. What I'm going to do is I'm going to differentiate first, then I'm going to substitute the value of 2 into the differentiated equation. Okay, let's differentiate it. It's all ready to go. So f dashed x is going to be equal to 3x squared plus 4x, and the 7 is going to go to 0. Okay. I'm going to substitute a 2 in now, so f dash 2 is equal to 3 times 2 squared plus 4 times 2, and I'll just work that through. So that's 3 times 4 plus 8, that's going to give me 12. 12 plus 8 is going to give me 20. Okay, so there's my value of f dash 2. Question 3. For question 3, the height h meters of a ball thrown upwards is calculated using the formula h is equal to 20t minus t squared, where t is the time in seconds after projection. Okay. Find the rate of change. So rate of change there should alert me to it's a differentiation question. Okay, and we're going to find the rate of change of h with respect to the time. Okay, and we're going to be looking at the rate of change when t is equal to 4. So that's what the question is really asking me to do. First thing I'll do is I'll start with my equation, okay? From there, I'm going to differentiate it. Rate of change, going to find out dh by dt. That's going to give me 20 minus 2t, okay? So that's that just differentiated there. What I want to do is I want to find out the rate of change of h when t equals 4. So I'm going to sub 4 in there and just calculate it out, okay? So dh by dt, when I'm substituting in a 4, is equal to 20 minus 2 times 4, 20 minus 8, that'll give me an answer of 12, okay? That's question 3 complete. I'm going to move now on to question 4. Now I realise that we're moving reasonably quickly through the questions, I don't want to take up too much time with the video, but you can always replay it and see if there's anything that you need to work on from there. Right, the amount of drug in milligrams remaining in the bloodstream T minutes after administration is given by this formula that's here. Find the rate of change, there it is again, rate of change of the amount of drug in the bloodstream when T equals 36. Okay, right, so I'm going to start with my formula. Because it's a rate of change I'm finding, I'm going to differentiate it, but I've got to prepare that part before I differentiate. So let's go ahead and do that. So that's going to be 300, that's going to be T to the power of, remember that's a 2 there and a power of 1 there. So that gives me a power of a half. And I've got minus 15 sitting here, 15T. From there, what I'm going to do is I'm going to differentiate. So I'll call it A dash T. That's going to be differentiated. A half times 300 is going to give me 150. T to the power of minus a half. If I take 1 away from a half, gives me minus a half. This one here will go to minus 15. Okay. Right, and I'm going to substitute a value in 36 into this this equation now, this differentiated equation. So what I'll do is I'm going to prepare this a bit back into the root form so that I can see what I'm working with. Okay, so that will be 150, and I'm going to go for T to the minus a half. Oops, sorry, T to the power of a half on the bottom there. Okay. T to the power of a half, well that's going to work out to be the square root of T. Now I'm going to substitute my value of T into the equation. So A dashed, when I'm substituting T is 36 into this equation, so I've got 150 over root 36 minus 15, and from there all I need to do is to calculate that through. Right, so from here what we've got is I've got 150, square root of 36 is going to give me 6, minus 15. So 6 into 15 is going to give me 25, minus 15, so my final answer there is going to be 10. And if I'm looking at what we've got is that's going to be the amount of drug in the bloodstream, okay? Or, sorry, that's going to be the rate of change of the drug in the bloodstream when T equals 36. Okay, it's going to be in milligrams per, and if we just look at what the time is in, and the time there is in minutes up at the top. Okay, milligrams per minute. Question 5. Okay, the point A, minus 1, 7, lies on the curve with the equation y equals 5x squared plus 2. Find the equation of the tangent to the curve at A. Okay, so find the equation of the curve, the tangent to the curve. I'm going to have to find the gradient. After I find the gradient, I've got the point, so I'll substitute it into the general equation of a straight line to work that out. To find the gradient, what I'm going to do is I'm going to start with my curve equation. I'm then going to differentiate it. When I differentiate it, that gives me what I would like to think of being as a gradient equation. So when I find the gradient equation, that's going to be 10x and the 2 goes to 0. So it's going to be 10x. That's my gradient equation. Right, so to find my gradient, I'm going to substitute the value of x in here. So what I've got is I've got my x value there, my y value there of the point that I'm interested in. To get the tangent. So my gradient, when I substitute the x value of minus 1 in there, is 10 times minus 1, which should just give me an answer of minus 10 or negative 10. Okay, so negative 10 for my gradient. So what I'll do next is I'll substitute the gradient I just worked out and the point that I've got that I'm interested in, minus 1, 7, into the equation of a straight line, which is going to be y minus b equals mx minus a. Okay, remember that's going to be my a value, that'll be my b value, so a and b, and there's my m value that's there. So I'll just go for that. Okay, so what we've got is y minus the b, which is 7, is equal to m, which is minus 10, x, and it's minus 1. Okay, you could make that a plus if you like. I'm going to multiply this one out at this side here to work that out. So that'll give me negative 10x. That'll be a plus 1, so that's going to give me a minus 10 that goes there, because it'll be minus 10 times plus 1. I'll then gather it together, so I've got minus 10x there, take that 7 over, and that there, when that comes over, it's going to be a plus 7, so that's going to give me minus 3. So that would be a reasonable answer there. If I was going to set it up for simultaneous equations, I would bring the 10x over to that side, and leave it like that, and start working from there. So any answer that's kind of similar to this one that's here would be acceptable there. Okay, question 6. Right, question 6 is asking us to find the equation of the tangent to the curve y is equal to 2x squared plus 7 all over x at the point where x equals 1. So the equation of the tangent. So I'm going to find the gradient. I'm going to have to find the y coordinate when x is equal to 1, and then I'll substitute it into the general equation of a straight line. Right, first things first, let's get this equation written down and we'll start working from there. Plus 7 over x. I'm going to have to prepare that because I've got an x value on the bottom. That's x to the power of 1 on the bottom. So what I can do from there is lift that to the top, and that will become x to the minus 1 that's sitting there. So that's 7x to the minus 1. To get the gradient, remember, dy by dx, if I differentiate, that gives me my gradient equation. So for my gradient equation, that's going to be 4x to the power of 1, and that will be minus 7x to the minus 2. Okay. I know I'm going to be substituting a value in, the x is equal to 1, so what I'm going to do is I'm going to prepare that a bit further. I'm going to take it back, this to the minus 2 to the bottom again. So there's the 7 that's sitting there, and that'll be x to the power of a positive 2. That will allow me to substitute the numbers in and work it through a bit easier for myself. Right, here we go. So what we'll do is we'll substitute that x value in of minus 1, and we'll work out and see what gradient this gives us. So over minus 1 squared. Okay. So what I've got there is minus 4. I've got minus 7 on the top there. That squared is going to give me a positive 1. So that's going to be really minus 4. Take away another 7. That'll take me down to minus 11. That's my gradient that's sitting there. So to find my y value for my coordinate that I need to put into the equation of a straight line, I'll substitute this value straight into this equation here, and that will give me my y value, because that formula there says y equals. So if I substitute an x value in, it tells me what y is. Okay. So this one here, what we'll do is we'll substitute 1 into this here. Whoop, I've just looked back here. I've substituted a minus 1 in here. I'm going to go back and correct that if that's okay, guys. So what I'm going to do is I'm going to substitute a 1 in. Okay, so that'll be a positive 1 there. This will be a positive 1 there as well. When I substitute that in, that will give me a positive 4. That'll be a minus 7 that's there. Minus 7 over 1. So that'll give me a minus 3. Okay. Oops. Okay, so made a mistake there. Glad I could see it and I corrected it. Let's go ahead and we'll try and get this one sorted out. So substitute a 1 in, okay, that's going to be 2 times 1 squared plus 7 all over 1. So that's going to give me 2 plus 7, so that should give me a value of 9. So my coordinates are going to be, so that would be the point of contact. So the point of contact is going to be 1 is my x coordinate from there, 9 is my y coordinate from there. So what I'll do is I'll substitute the gradient of minus 3 and the point of contact 1, 9 into the general equation of a straight line. Okay. Right, so that's my a value, that's my b value. let's go for that. So we've got y, and it's going to be minus 9 is equal to minus 3x minus 1. Just multiply the right hand side out first of all. That'll give me minus 3x, that'll give me plus 3, and y is equal to minus 3x, bring that over, plus 12. Okay? Or if I was trying to prepare it in some way, I could go for that there. So any of these answers would be fine. That would be acceptable. Okay, so that would be the equation of the tangent to the curve, okay, where x equals 1. Okay, apologies about this wee mistake that I made here, but glad I corrected it before we went on. Okay, if I made any others, I'm sure you can let me know about it. Okay then, right, question 7. Right, a curve has equation, here we go there, okay. Find the equation of the tangent to the curve at the point P where x equals 2. Let's go ahead and get our gradient first. So we're going to start for part A, we'll get our gradient. Starting with the equation. Differentiate it. Remember, when we differentiate it, we get a gradient formula. So let's get that one going. So that's going to be 3x squared minus 8x plus 2, and the 1 when we differentiate it goes to 0. What I'm going to do is I'm going to find my gradient. When I substitute a positive value of 2 in, that should give me 3 times 2 squared minus 8 times 2 plus 2. Okay, and we'll work this one through. So that's going to be 4. 4 times 3 is 12. That'll give me 16 there. So it's a take away 16 plus a 2. 14 take away 16. That'll give me a minus 2 for my gradient. For my point of contact, I'm going to substitute x equals 2 into the y equals equation, okay, for the point of contact, right? Let's go for that. So y2, so straight into the equation that's just straight up at the top there. It says y equals, gives me my y coordinate when I put in my x coordinate. So it's going to be 2 cubed minus 4 times 2 squared plus 2 times 2 minus 1. Working this through, that gives me 8, that'll give me 4, that'll give me minus 16 that's there, that'll give plus 4 minus 1, okay? So gathering some things together, we've got 12 there, take away 16 is going to give me minus 4, minus the 1 gives me minus 5. So my point of contact, hope I'm still on the page here, yep, point of contact is going to be 2 for my x value, which I was given, minus 5 for the y coordinate that I worked out. Right, so got that just now, and let's go ahead and substitute into the equation of a straight line. So what we'll do here is we'll substitute gradient equal to minus 2 and the point of contact 2 minus 5 into that general equation, which is y minus b equals mx minus a. Very common, we use this all the time, so it's really good to have this just kind of running straight. So y, and that'll be, okay, minus 5 is equal to minus 2 for my gradient, x minus that 2 that's sitting there. When I multiply that bracket out on the right hand side, I've got y minus 5 is equal to minus 2x plus 4. From there, what I'll do is I'll take the 5 over to the other side, minus 2x, that 5 coming over, we'll add 5 on, so that'll give me plus 9. And if I had to prepare it in any other way, plus 2x is equal to 9. Okay, if I had to get anything ready for some simultaneous equations or anything. So that's part A complete. Part B, okay, so for part B, what it's asking us to do is it's asking us to find, so that, and it's actually giving us the information for the normal. So the normal to the curve at P is the straight line through P, right, through the point that we've just worked out, which is perpendicular to the tangent at P. So if you just think about it, what we've got is if we've got a curve and we've got a tangent to that curve, so there's a tangent that's drawn there, a normal will be at right angles to that. So there's a right angle. So we know how to work out a right angle gradient if we're given the gradient of the tangent. Okay. So let's go for working out our gradient. So we've got our gradient here. So first thing I know that the gradient of the tangent is equal to minus 2. So generally the way I would think about it is, so the gradient of the normal, all I'm going to do is flip that over. So just imagine that's got a 1 over there. So it's minus 2 over 1. Flip it over, it's 1 over 2, and I'm changing the minus to a positive. Okay, so that's just a half, that'll become. And that's, remember, that's reason for that is that if I multiply the two gradients together, I should get minus 1. So a half times minus 2 is going to give me minus 1. So I know that that gradient's the one that I'm going to use. Okay, so I have to work out the equation of the normal now. So I've got my new gradient. So I'm going to substitute my gradient of a half and the point that we worked out earlier, which is 2 minus 5, into the general equation of a straight line. Right, so that's going to be minus 5, isn't it, that's going to be there? Is that minus 5? So, oh dear, I can see another mistake. It is getting late, it's nearly midnight, but hey, I'll go back and fix that previous one. So that's going to be minus 5 is equal to a half x, and what we've got minus 2 there. So that's going to be y plus 5 is equal to, just multiply this out. We could multiply it that way, or what I'd kind of normally do with this type of question is I would multiply this side by 2. So I would get 2y there, I would get a positive 10 going there, and then I'd multiply out by the numerator on the top. So that'll give me x, and that'll be minus 2. So that gets rid of the fractions that I'm working with there. So what I've got for my equation is 2y is equal to x, and if I take the 10 over, it'll be minus 12. So that's the equation that I would have of the normal. Let me go back and correct this equation here. Okay, so let's see. So I've got a minus 5 that's there, and I've got y minus b, so that there is going to be a positive 5 that appears there. Okay, so that will be a positive 5 there because it's minus b. That's my value for a, that's my value for b. Okay, right, so if I've got a positive 5 there and I bring it over to the other side, then this is going to be minus 1. Okay, if I bring the minus 2 over to that side, positive 2x there, and that will be equal to minus 1. Okay, no great excuses that it's getting dead late. Sorry about that, but here we go. Let's move on. Right then, question 8. Right, the gradient of the tangent to the curve, here we go, at the point Q is 4. So the gradient is 4 at the point Q. That's the way the question reads here, okay? Find the x coordinate of Q. Right, so what I know is, I know that if I differentiate, I'll find a gradient formula. So I'm going to go ahead and do that first, okay? I'll get down the equation. If I differentiate it, I find the gradient formula. So that's going to be 2x plus 6. What I'm going to do is, because it tells me the gradient is equal to 4, so I'm going to make this side equal to 4, okay? So what I've got is, I've got 4 is equal to 2x plus 6. So from there, I'll bring the 6 over to there, which gives me, I'll just write out 4 minus 6 equals 2x. So that'll give me a minus 2 that's here. It's equal to 2x. So x is equal to this minus 2 divided by that 2. So x is equal to minus 1. So there's the x coordinate of Q. Okay? Last question. Here we go. Right, given f of x is equal to x squared plus 1 all over root x, find f dashed x. So all we're going to do is we're going to differentiate. We're going to have to deal with a bit of fractions, but we can cope with that, I'm sure. I'm going to prepare it first of all, okay? So what I'm going to do is I'm going to change that into index form. So that's going to be x to the power of a half, okay? Next, what I'm going to do is I'm going to split the fraction. So it's x to the power of 2 all over x to the power of a half plus 1 all over x to the power of a half. Now, what I'm going to do here with my indices, I'm going to change 2, okay, I'm going to change 2 into 2's on the bottom, so that's going to be like 4 over 2, if that's okay with you. 4 over 2, or if I've got 2 and I'm going to take away a half, that's going to leave me with 1.5, and for 1.5 I'm going to write it as 3 over 2, okay. This one here, I'm going to lift that to the top, so it's going to give me x to the minus a half. That's it prepared, ready to differentiate it. I'm going to go and do it, and that'll be the last of these questions here. So 3 over 2x, taking 1 away from this, okay, 1 away from 1.5 leaves me with a half. Or generally what I would do is take the 2 away from a 3, gives me 1 on the top, and I'm working with 2's or halves on the bottom, okay? So that's the way I would usually work with that. Multiply this one, so that's going to be minus a half x to the power of, and I'm going to take 1 away from this one. When I take 1 away, the 2 that I'm working with, I'm taking 2 away from minus 1, gives me minus 3. I'm working with 2's on the denominator, and that would be my final answer there. Okay. Right, so if I had to write it with positive indices, I would change some of the things that I've done today. I've not been asked to do that. I'm going to leave the answers as they are just now. So hopefully it's been a benefit to you. You've seen how I work it through. The couple of wee mistakes that I've made, I'm glad I went back and corrected them at the time, or else, you know, some of the things would be wrong that I'm posting. I'm trying not to do that, but to be honest, it's quite late tonight, and that's us done the revision for differentiation, or for my class anyway, that's the homework for differentiation. Okay, right, so that's us complete for today. Cheers.